Hi everyone, my name is Amira Masterina from Group 4F and this is our video for Integrated Project, Process Safety and Loss Prevention. Phenol or monohydroxybenzene is a part of an organic compound family that consists of a hydroxyl group attached to a carbon that is part of a benzene ring. It is closely linked to alcohol, but it has a stronger hydrogen bond. The National Fire Protective Association or NFPA classifies phenol as extremely hazardous. Phenol can be produced from the air oxidation of cumene. Towards the end of the production process, there is a distillation column used to separate phenol from other constituents such as nitrogen and acetone. In this video, we will be identifying the hazards present in the distillation column, and next, a hazard study will be done based on the hazards identified. Lastly, recommendations to improve the safety aspect of the distillation column will be proposed. Without further ado, let's go to the first agenda.
Hi, my name is Rashidi. Now I will talk about the hazard in this project. Hazard is any source of potential damage, harm or adverse health effect on something or someone under certain condition of work. Now let me explain the hazard in a distillation column in the production of phenol from cumene. First, the substance enter the distillation column are mostly flammable liquid. There's a lot of heat involved in the distillation column and it will give a high input heat at the reboiler and condenser. If one of these malfunction, it will cause a major effect to the distillation process in the column. For example, if a condenser is breaking down, the column will be overpressure and it will cause explosion. Second, overheating is also a hazard in distillation column. It is important to know the heat transfer that the column can reach, as this is normally the maximum heat that the distillate and residue can be exposed to. Temperature set in the column must be optimal so that it obeys the heat transfer of the column and the component inside. Lastly, flooding can occur if the column is not designed well. Flooding can be defined as the excessive vapor flow causing liquid to be entrained in the vapor up in the column. Flooding may also result on the increasing the pressure and temperature inside the column. This also will lead to the fire and explosion inside the distillation column. That's all. Thank you.
Okay, hi, I'm Rafi, and I will explain about chapter 4b, which is hazard study on the distillation column. So first is, what is hazard? So hazard is the systematic technique to identify potential hazard and operating problems. So basically, hazard is has stand for hazard and op stand for operating problems. So in hazard, there are steps or procedure that needs to be followed. A list of guide words is used to generate deviation from normal operation corresponding to all conceivable possibilities. Guide words covering every parameter relevant to the system under review. In our case, is the distillation column system. Hazard technique is done in a table which consists of 6 sections, which are study note, process parameters, deviations, which is the guide words, possible causes, possible consequences, and action required. For each hazard, we will evaluate for each of the sessions. So we'll take an example of our first hazard, which is overpressure. The study note is like where is the source of the hazards come from. So for our first hazard is the overpressure, and overpressure is come from the reboiler. And the second section is the process parameters, and process parameter is the parameters that we look at. So in our first hazard is the heat, and the deviations, the guide word is high and low, which is the heat is high and when is the heat is too low. It is because of the malfunction of the unit itself and the blockage in the pipeline. So what is the possible consequences? Is the temperature will increase, will be overpressure and lead to fire and explosion. And action required is install a pressure controller and also install a cooling water high temperature alarm. So this is how the hazard is done which is we identify the potential hazard and operating problems. So we will do the evaluation for the hazard technique for each of the hazard that we identified. So that's all for the hazard study on the distillation column. Thank you.
Hello, my name is Alyssa. For this part, I will be presenting the recommendation to improve the safety aspect of the distillation column. There are two aspects that can be improved. The first one is in terms of the process control measures, and another one is from the aspect of chemical reaction. For process control measures, to prevent hazards related to pressure, the most common safety method is the installation of pressure relief valves for an efficient and fast pressure reduction together with the usage of dynamic simulation. This model is a new method for the design of safety devices for distillation columns after an operating failure. This method differs from the current usual methods, whereby this method allows detailed investigation of the important parameters like pressure and temperature and the dynamic behavior. In the case of pressure relief event, this system can reduce 85% of the relief flow. For chemical reaction hazards, decomposition of residues is a major concern. Several operations should be attempted in order to prevent decomposition from occurring. This includes implementation of heating medium temperature below the decomposition temperature and continuous distillation to reduce inventory. In a worst-case scenario, inherent safety and/or pressure control measures are not sufficient. Then, protective steps are necessary. Common options to be taken into considerations are quench, drawn out, and relief venting. That's all from me. Thank you.
In conclusion, we have identified the hazards related to the distillation column in this process, which are overpressure, overheating, and also flooding. Next, a hazard study was conducted allows us to determine the cause, consequences, and what actions we can take to mitigate this hazard. Next, our recommendations include using a pressure relief valve with dynamic system, and also using quench, drown out, and pressure relief to mitigate the effect of decomposition. Thank you.